Okay, guys. All right, we're having a look at gradient and Y-Intercept now. So we're up to B, 12B. We were talking about that car that was travelling at 60 kilometres an hour. We looked at that in the earlier examples. There's two points on the graph we'll look at. First one is 160, and the other one is 120. Okay, so they're down here, 160 and 120. Okay. What we are looking at with that is that for every 1 unit increase on the independent variable, we went up by 60 on the dependent variable. That makes sense? We went from 160 to 120. Yeah? We went up by 1 on the horizontal, on the independent, and we went up by 60 on the dependent. Cool? Right. For this function, we can say that the gradient is 60. Okay, now this is where you're going to have to actually pay attention just for the hell of it. For this function, we can say that the gradient is 60. Can anyone tell me why we can say that the gradient is 60? You've got to think back to what a gradient is. What is a gradient? It is a rate of change, but we don't describe it as that mainly in this course. We do it in mathematics. Yes, what would we call that? You're going to have to use words, Mr. Searle.
Slope.
Slope, excellent. It is a slope. But the gradient is not just the slope. What is it about the slope that the gradient tells us?
The altitude is the incline.
The incline.
That's it.
It's... Okay, there's two hills. One of them is easy to walk up, the other one's hard. Why?
One's steeper.
Steeper, that's it. It's the steepness of the slope.
We just got it.
Okay? It is the steepness of the incline. Incline and slope are kind of the same
One
thing.
of them's got rocks and
Yeah. One of them has a path. And a travelator.
one's got a yellow brick road.
Yellow brick roads are always easy to travel on. Alright, so this is the important bit, and this is where Dylan read this from.
What?
The gradient is the rate of change.
Where you walk from?
That, when you were talking about rates, I'm assuming you were reading from that. No? You knew it? You're a lot brainier than you make out to be? Alright.
Okay.
The gradient is the rate of change in the dependent variable for 1 unit increase in the independent variable. Okay? 1 unit increase in the independent variable. Okay? What that's saying is how high do we go, or how much higher do we go for every 1 unit that we go across? Okay? Sounds a bit weird at the moment, but it can be described in a very, very easy formula. Vertical change in position on top of horizontal change in position. Now, if we wanted to talk about that in an even easier fashion, vertical change in position, what would we call that? If you're in an elevator and you're going up in the elevator, your vertical position is changing. What can we call that? Starts with R and ends in I's. Hey, well done.
I didn't think about that. I'm pretty sure it's raised.
Okay, we're going to talk about it as the rise over the horizontal change of position. Run. Okay? So that's the simplified version that you would have learned in year 7, year 8, year 9 or year 10, and or all of them. Okay? Vertical change of position is your rise, horizontal change of position is your run. Now, it's given as the letter M in maths. Now, a lot of people ask, well, why do we use M and not G for gradient? I cannot give you a definitive answer other than the fact that an M is nice and curved and there's gradients all over it. I don't know. I'm making that up. I don't know why they use M, but they do. I'm sure they've got a legitimate reason.
It's so you can think about it.
Yeah. It's actually probably because it's from a Greek or a Latin word and I'm just too stupid to know. But M is the one we use for gradient. Cool? Alright, using this formula, the gradient can be calculated. Okay? A lot of the times you'll be given the gradient in the formula, but sometimes you have to calculate it. So the graph at the right, I'll just scroll across, shows C equals 2, plus 0.5D. Okay? I don't care what the formula is about, it doesn't really bother me. What I want to do is calculate the gradient. Okay? So what we have to work out is what is our rise, what is our run. Okay? So have a look at this. The easiest way to do this is pick numbers that are whole numbers. If you can possibly avoid it, don't try and use fractions or decimals. Try and make it as easy for yourself as possible. So what we're going to do is we're going to pick a couple of whole numbers. They've picked them for us. They've picked the point 23 and the point A6. 8, 6, sorry. So the first thing we have to do, M equals rise over run. Okay, what's our rise? How much has it gone up between that point and that point? 3 units or 3? Does everyone agree with that? It's gone up from 3 to 6. So it's gone up 3. I'm going to assume that all those lack of nods is a yes.
Over 6.
What is our run? How far has it gone horizontally? It's gone from 2 to 8, which is how many units? 6
units.
So rise over run, 6 units. Now, 3 over 6 is a fraction. Can we simplify that?
Half. 1/2.
Half. So our gradient is a half. Everyone happy with that?
Yeah.
Rise over run. You just calculated it. We don't know anything about the graph other than the fact that we've now worked out the gradient. Cool? Excellent.
It's already written down.
It is already written down. Most of these are already written down. Okay, so here we go. For the linear function drawn below, calculate the gradient. So what you need to do is pick 2 points. Find 2 points that are going to be nice and easy. I'll give you a hint.
There's already one on there.
0, 0.
7.
Sorry? What?
1, 4.
You're a donkey.
1,
Alright,
4.
I would
There's
pick...
already 2 points written on there.
Which ones?
There's 2 dots.
Oh, okay, you want to use those ones? Fine. I normally use 0, 0 because it's easier for me, but...
I'll see how it is.
Which one do you want to use? You want to use their ones? Okay, right next to it, what the point is. What's the point there? 1, 4. Excellent. What's the other one? 520. Awesome. Okay, so you now got your 2 points. So you want to do your rise over your run. So M equals rise over run, which equals, what's your rise?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
My silence is deafening. Okay, easiest way to work out your rise is it was at 4, it's now at 20.
Oh,
How much has it gone up?
16.
Come on guys, subtraction.
16.
16. 16. Alright, and what's your run? You've gone from 1 to 5. Where are you?
4.
4. Awesome.
Got it.
Okay, can we simplify that?
1, no. 4.
Yes.
It is 4, but if in doubt, if you're not sure how to simplify fractions because you're also itchy, put it into your calculator. Sorry? How many 4s going to 4? 1. How many 4s going to 16? 4. So you end up with 4 over 1, which equals 4. So your gradient is 4. M equals, M equals, M equals. Everyone happy with that? Excellent.